In this video, we will discuss trigonometric functions. Using trigonometry, we can determine the measure of either acute angle of a right triangle if we know the measure of at least two sides of the right triangle. The figure below shows a right triangle ABC with the sides of the triangle labeled according to their relationship with one of the angles. The left triangle is labeled with relationships according to angle A, and the right triangle with relationships to angle B. The hypotenuse of the left triangle is the side opposite the right angle of the triangle, and the hypotenuse forms one side of angle A and of angle B. The other side that forms angle A is the adjacent side of angle A. The third side of the triangle is the opposite side of angle A. We previously addressed the hypotenuse of a right triangle. The adjacent side of an acute triangle of a right triangle is the side that forms the angle with the hypotenuse. The opposite side of an acute angle of a right triangle is the side that does not form the given angle. The three most commonly used trigonometric functions are the sine, cosine, and tangent of an angle. The sine, cosine, and tangent are defined as ratios of the sides of the right triangle. For convenience, the sine, cosine, and tangent functions are abbreviated as SIN, COS, and TAN, respectively. In the standard right triangle, side A is opposite angle A, side B is opposite angle B, and side C, the hypotenuse, is opposite angle C, the right triangle. So, sine of A is equal to the side opposite of angle A divided by the hypotenuse, or A over C. The cosine of A is equal to the side adjacent to angle A divided by the hypotenuse, or B over C. And the tangent of A is equal to the side opposite of angle A divided by the side adjacent to angle A, which is equal to A over B. Likewise, the sine of angle B is equal to B over C, the cosine of angle B is equal to A over C, and the tangent of angle B is equal to B over A. The book offers up the suggestion that you remember the phrase, Oscar had a heap of apples, to remember that the sine is given by opposite over hypotenuse, OH, the cosine is given by adjacent over hypotenuse, AH, and the tangent is given by opposite over adjacent. I personally do not think this is a very good mnemonic, but if it works for you, fantastic. The book also recommends you remember some old hogs come around here tasting our apples, which has the advantage that it actually includes the S, C, and T to remind you which function is associated with which set of letters. I've always found the abbreviation SOHCAHTOA most useful. It gives us all the information we need. The book chooses a somewhat racist way of presenting this, which I will not include here. I will instead suggest that you watch the Gettin' Triggy with It video I've posted on Moodle, or Google it for yourself. It's on YouTube, and I have subjected my students to this video for years. To write the trigonometric ratios for a right triangle given the measure of at least two sides, first, identify the acute angle that is being used. Second, identify the hypotenuse, opposite side, and adjacent side in relation to the acute angle selected in step 1. Third, write the appropriate trigonometric ratio. And fourth, simplify the ratio or convert to a decimal equivalent. For example, find the sine, cosine, and tangent of angles A and B in a triangle that has sides A equals 7 inches, B equals 24 inches, and C equals 25 inches. We know the side opposite angle A is A, and the side adjacent is B. Likewise, the side opposite angle B is B, and the side adjacent is A. This allows us to find the appropriate trigonometric values. For A, the sine of A is equal to the opposite over the hypotenuse, which is 7 over 25. The cosine of A is equal to the adjacent side over the hypotenuse, which is 24 over 25. And the tangent of A is equal to the opposite over the adjacent, which is 7 over 24. For B, the sine of B is equal to the opposite over the hypotenuse, which is 24 over 25. The cosine of B is equal to the adjacent over the hypotenuse, which is 7 over 25. And the tangent of A is equal to the opposite over the adjacent, which is 24 over 7. You may be asked to write these values as decimals. If so, just evaluate the fractions on your calculator and I'm not sure what appropriate was supposed to be. It was supposed to be round appropriately. Since most of these values have 25 in the denominator, the only two which may cause problems are the tangents. But we can evaluate the tangent of A equals 7 over 24, which is about 0.29166667, which is approximately 0.2917 when rounded to the nearest 10,000th. In studying similar triangles, we found that corresponding angles of similar triangles are equal and that corresponding angles are directly proportional. These properties of similar triangles lead us to a very important property of trigonometric functions. Every angle of a specified measure has a specific set of values for its trigonometric functions. The book recommends using a calculator to find trigonometric values. Any scientific calculator will have ways to find these values. Any graphing calculator, your phone, which you likely won't be allowed to use on tests in a classroom. Since you're looking at this on a computer of some sort, you can just switch over to Google and look up sine 30 degrees if you feel the urge. It's 1/2, by the way. The book talks about how to use a calculator to find trig values. The thing is, every calculator is a little bit different. On an iPhone, you have to enter the number, then press the button corresponding to the function you're looking for. On a TI-84, there's a button that gives you a list of functions. One set of instructions is not going to help everybody. I encourage you to use your calculator to find the values of trig functions. I know the values for a handful of angles, multiples of 30 degrees, 45 degrees, 60 degrees, and 90 degrees off the top of my head, and I can calculate a number of others based on formulas I know. But I can't just tell you the tangent of 73 degrees. Get used to your calculator and ask me if you have questions. If we have the sine, cosine, or tangent of an angle and want to find the measure of the angle, we use an inverse operation. The inverse trig functions are generally written in one of two ways. More commonly, we will write them with a -1 superscript. And we read these as sine inverse, cosine inverse, and tangent inverse. But sometimes we talk about arc functions, such as arcsine, arccosine, and arctangent, which are the same thing. I will use the former notation, but if you encounter arc notation in the future, you'll know what it is. Again, I can tell you a handful of inverse trig values off the top of my head. If you tell me the sine of an acute angle is 1/2, I can tell you that the angle is 30 degrees. But for most trig values, which range from -1 to 1 in the cases of the sine and cosine, and from -∞ to +∞ in the case of the tangent, I don't have a clue. You need a calculator, and again, you need to learn for yourself how your calculator works. But ask me if you have questions. For example, find the angle in degrees given the trigonometric value. Theta represents the unknown angle measure. Round the nearest 10th of a degree in parts A and B, and the nearest 1,000th of a radian in part C. So that first line about finding the angle in degrees was a little incorrect. Sine of theta equals 0.6561. I'm using my iPhone for this. I turn my phone horizontal so it goes into scientific calculator mode. I check the button in the bottom left to make sure I'm in degree mode. If it says DEG, you're in radian mode. If it says rad, you're in degree mode. I know that's a little counterintuitive. I also press the second button, second from the top on the left, to bring up the secondary function options, since the inverse trig functions are not on the main page. Now I enter 0.6561 in the number pad. The sine inverse button is the second column from the left, second row from the bottom. I touch that button and the answer comes up, 41.003110496250991. We only want the answer to the nearest 10th, so we round this to 41.0 degrees. Cosine theta equals 0.4226. Same process. I check to make sure I'm in degree mode, still am, and press the second button. I enter 0.4226 on the number line and touch the cosine inverse button, immediately to the right of the sine inverse button. The answer that comes up is 65.00115448169833, but we round this to the nearest 10th, 65.0 degrees. Tangent of theta equals 2.825. The only real change that needs to be here is that we need the calculator in radian mode. So I press the button marked rad in the bottom left corner, then enter 2.825 on the number pad and touch the tangent inverse button to the right of the cosine inverse button. The answer that comes up is 1.230,578,215,150,213. Rounded to the nearest thousandth, our answer is 1.231 radians.